Hello everyone, welcome to my channel. So today we'll be discussing the very basics of sine and cosine of obtuse angle. Before I dive into this concept, it's very important for you to understand the word acute, in a similar way, obtuse, and finally reflex. Now, these are the three types of angles that we have. When I say the word acute, it means something that is less than 90. An example of that would be maybe perhaps 12 degrees, similarly 40 degrees, 35 degrees, even 55 degrees as well. All these are examples of acute angle. In a similar way, when I say the word obtuse, it means something that lies in between 90 and 180 degrees. Again, an example of this would be perhaps 100 degrees, maybe 120 degrees, 130, anything that goes till 180. And finally, we have reflex, which means something that is in between 180 and 360. An example of this would be 240 degrees, 270. Again, the list goes on and on. Now, if you are in O levels or doing IGCSE, I would expect you to understand that there are two important identities that we have. The first identity is sine of x is equal to sine of 180 minus x. And the second identity is cos of x equals minus cos 180 minus x. And I will explain this to you just in a short while. So let's start off with the first identity that I've written. And let me take an example for this. In your calculator, I would expect all of you to have your calculators with you while we are doing this practice session. Now, let's assume I've given you a question and I'm telling you that sine of x perhaps is 30. Can I say sine if I've taken x as 30? So according to this identity, it should be sine and then 180 minus what we just took x as 30. What does that give you? This on this side, on the right side, it should give you sine 150. And on this side, it should give you sine 30. Now, you might be wondering that these are different values. I want you to use your calculator, everyone, and I want you to figure this out. If you put sine 30 in your calculator, you'd realize it comes out to be 1/2 or 0.5. And the same answer will be on the right side as well. That means if you had taken sine 150 as well, that should also give you the same answer as 0.5. You can try this out if you don't believe my words, although you should. Now, if this identity is clear, let's try to understand why is that the case. So the idea is something that really, involves the concepts of ad maths. And I wouldn't expect anyone who's doing O levels to know this, but yes, it might be a nice idea for you to know something more than the identity. So honestly, in terms of your exam, as long as you can memorize this, you should be fine. This identity and similarly this identity. But you see, the problem is I can't really memorize something when it comes to math. I would like to know the concepts, and my concepts, they all stem from ad maths. So let's see. If I ask you, can you please label out this axis? Generally, we start from this side and we go in anti-clockwise. So that has to be 0, this has to be 90, this has to be 180, this has to be 270, and then finally the circle repeats at 360. You can see that there are 4 boxes that we have. One over here, one on this side, one on this side, one on this side. And we don't usually call them boxes, we call them quadrants. And we start from this side. This is going to be my first quadrant. This over here is my second quadrant. This over here is my third quadrant. And this right here is my fourth quadrant. You see, everyone, if I ask you, can you please, using a protractor, can you please make 30 degrees? Now, if I were to place my protractor in this direction, so let me just do an example for you. Let's say this is how my protractor looks. Now, you do understand that on a protractor, there are 2 scales. One which goes from this side, 0 to all the way till 180. In a similar way, there's also another scale from this side, which goes again from 0 to 180. So if I ask you, can you please make 30 degrees, where exactly will you be making it? Will it be on the right side or on the left side? Will it be this 30 or will this be this 30 over here? Again, that's the problem. This is exactly what you need to realize, that you should be able to draw 30 on both sides. This is absolutely fine. There's no compulsion that it says that the 30 has to be on the right side. This is where you need to understand that the first angle that we have made, according to this scale and generically how the convention works, yes, we would start from this 0 and we will say that's 30. This is also 30, but again, this is 30 which is raised on this side. It's not 30. This angle that we have drawn, the second red line, it's going to be 180 minus 30. Why are we subtracting? Because it's 30 degrees above. So I can say 180 minus 30, which gives us 150. The concept is that it's just two different angles. And since we only deal with sine and cosine, sine will stay same in the first and the second quadrant. So if I had taken sine of 30 over here, sine 150 will also be the same. This is where this identity comes into play. Again, like I said, you're only supposed to know this concept that sine x is equal to sine 180 minus x. In a similar way, the second property over here, let's again take the same example with the same value, which is cos 30. So let's say we have cos of 30, and then we have minus cos, and then 180 minus 30. This would give you cos 30. And on the right side, we'll be having minus cos 150. Now, everyone, cos 30 in your calculator should give you square root 3 over 2. In a similar way, if you were to compute all of this with minus, if you did in your calculator minus cos 150, that should also give you square root 3 over 2. But of course, there's a negative over here. What you need to realize over here is that in this case, cos 150 is going to give you minus square root 3 over 2. And that again will give you plus square root 3 over 2. So the question that you should be, I'm sure some of you are very confused as to what on earth is happening. You need to realize, everyone, that we have two important identities, these two important identities. And there are certain properties when it comes to this quadrants. So like I said, that's the first quadrant, that's the second, that's the third, that's the fourth. In O levels, we don't deal with the third and the fourth quadrant. That is the reason why I'm not discussing it. My primary concern in O levels, again, third and fourth quadrant are part of ADMAS. In O levels, we only deal with the first two quadrants, the first one and the second one. In the first quadrant, you need to realize the sine value is always going to be positive. What does that mean? Take any angle between 0 and 90. Give me a number. Let's say we have 39. I want you to take sine 39. What does that give you? If you did this in your calculator, that's just going to give you positive. This should give you positive 0. Perhaps 0.629. Again, this is also positive. Take any other number. Maybe take sine of 59. Sine 59. What does that give you? That also gives you positive 0.8. What I'm trying to teach you over here is that if you take the sine of any value in between 0 and 90, you will get a positive answer. The point answer that you'll get, it's going to be positive. The same rule applies when it comes to 90 and 180 as well. That sine value in this quadrant is also positive. That means the first example where I took sine 30, it gave me positive 0.5. And similarly, sine 150, where does 150 lie? In the second quadrant. And isn't that also going to give you sine positive value? Yes. But for cos, you need to realize in the first quadrant, cos is positive. But in the second quadrant, cos value is going to be negative. Why is that the case? Again, the why, for why, you need to actually take ADMAS as to why does that happen. So in O levels, they would just expect you to know that sine is positive in the first quadrant, cos is positive in the first quadrant. In the second quadrant, sine is positive, but cos is negative. That is exactly what happened. So cos 30, which is again in the first quadrant, gave me positive square root 3 over 2. It's a positive value. In a similar way, cos 150, what does that give you? This gives you minus square root 3 over 2. That means whatever value that you get in the first quadrant, it's always going to be negative, same value, which is going to be negative in the second quadrant. If this concept is somewhat clear, if not 100%, that's completely fine. Let's quickly have a look at some practice questions. So let's see. This worksheet over here, I've uploaded this in the folder of O-level trigonometry. So it's OL and then trigonometry. That's the folder name in the Paper Hack website. Now, the first part over here says you are given that sine 40 is equal to 0.6428. My first question to you is, where does this lie? Where does 40 lie? So we just studied that 40 lies in the first quadrant. Okay, so if 40 lies in the first quadrant, everyone, what happens to sine? Sine value is going to be positive, right? That's what we discussed. What about cos? That's also positive. If that's the case for first quadrant, what's the case for the second quadrant? We said for sine, it's going to be positive, but for cos, it's going to be negative. That is what we have discussed so far. So if this does make sense to you, the first part of the question says, without using a calculator. So we can't use the calculator in this case. It says sine. So we know the property is sine x is equal to sine 180 minus x. Now, in this case, we know that x is 40. Sine 40 is equal to sine 180 minus 40. What does that give you? Sine 140. And what is this sine 40? What's the value of sine 40 that is already given in the question? Can I say that has to be 0.6428? Isn't that equal to the first part, which is sine 140? Without using a calculator, we have done this. In a very similar instance, we can say the second part of the question says cos 40. Now, I did mention this earlier as well, that if you were to use that identity, which is cos x equals to minus cos 180 minus x, what does that mean? I said if cos value is positive in the first quadrant, we do know that this lies in the first quadrant, 0.7660. Now, where does 140 lie? Can I say 140 lies in the second quadrant? It's an obtuse angle, cos 140. Wouldn't that be equal to the negative of this? That's it. We were supposed to just write down the values. That's all I did. In a very similar way, let's take a look at question number 2. Question number 2 says, solve the equation sine x equals to 0.8. Now, you do understand that when I take cos on the other side, that's going to be x equals to sine inverse 0.8. Figure out sine 0.8 in your calculator, and that should give you 53.13. When it comes to angles, we have a convention in O-levels and IGCSE, and that is we always round up to correct to 1 decimal place. So I can say that has to be 53.1. Now that I've done this, my first question to you is, where does this lie? First quadrant or second quadrant? I'm sure all of you said first quadrant. So we know that it lies somewhere over here, 53.1. But like I said, it would also lie in this quadrant as well. So this is 53.1. What do you think this is going to be? Like I said, you will always subtract from 180. So we know in this case over here that this has to be 180 minus 53.1, which should give you 126.9. These are the two values that I should get. How on earth did I knew that I'm supposed to work out for two different angles? Because the question says that my limit is in between 0 and 180. So they want us to list down all the angles that could be true. Now, if you took sine of this in your calculator, you'll see that the answer is going to be 0.8. Similarly, if you took sine of this as well, it should also give you the same answer as 0.8. So I hope the concept is building, In a very similar way, let's take a look at question number 3. For question number 3, it says sine of m is equal to 0.63. Now again, is this positive 0.60 or is it negative? I'm sure all of you probably said it's positive, right? Where does where is sine value positive? We said it's positive in the first quadrant and the second quadrant. We know this is where sine value is positive. So I'm very sure about it that this value, without even reading the question further, I know that this has to be in the first quadrant or the second quadrant. Now that we have figured this out, the next part of the question says that it's actually sine, in this case, one solution is m equals to 141. Let's draw this out like a rough sketch. So I know that 141 should be somewhere over here. That's how 141 looks like. Excuse my bad handwriting. I'm sure all of you already know this. Anyway, so we know 141 lies over here. And I'm very certain that there must be an angle that in the first quadrant that's also going to give us the same answer. Now, again, what's that identity? Sine x equals sine 180 minus x. So if that is the case, I can actually plug in the value sine 141. Let's just take x as 141. That's going to be sine 180 minus 141. I can say that's going to be sine of 39. If that is the case, what's the value for sine 141? We knew that if we plugged in 141, it gave us 0.63. So we are very certain that the question was asking us to find an answer that lies in between 0 and 90. So which number do you think that's going to be? In this case, it has to be 39 degrees. Please bear this in mind that in this question over here, they're just asking us to find the angle over here, which comes out to be 39. So my final answer will be 39. I will show this working. Oops. But the last step where I have to plug in the answer is where I should only write down the word or number, that is 39 degrees. So we know in this blank, just 39 goes. In a similar way, let's take a look at the next part. The next part of the question says cos of y equals minus 0.54. Again, my question to you, where do you think cos value is negative? In the first quadrant or in the second quadrant? We know that cos value is negative in this, and similarly, cos value is positive in this quadrant. We also know that this quadrant is in between 0 and 90, and similarly, the second quadrant is in between 90 and 180. So the question says that this value is negative in this quadrant. That is exactly what I have just said. One solution of the equation is this, 57. Now again, which value is this? It's a positive value. So we know that this lies in the first quadrant. Let's draw this out. That's going to be 57 degrees. In a similar way, I said this earlier as well, that this should also be 57. But is this really 57? Not really, because the count starts from this side. So we go in this anti-clockwise direction. And if I were to subtract 180 minus 57, this should end up giving me 123. If you don't believe my words, although this is a paper one question, that means a calculator isn't really allowed. But I want you to plug in cos 123 in your calculator, and you will see that you do end up getting this y value that is exactly what they were asking. So I hope the concept is building brick by brick. Let's try this question. So this is about trigonometry. It says in the diagram, BCD is a straight line. What you need to realize, everyone, is in O levels, especially in A levels, in Cambridge assessment, every certain line has a purpose. That means if they write down something as a straight line, that means they probably want you to understand that this has to be the sum of this line, or sum of angles. That's more appropriate. It's going to be 180, which means if this is a straight line, this angle and similarly this angle, they both would add up to form 180. They both would add up to have a sum of 180. The first part of the question says, again, what kind of triangle is this? 90. I did discuss this in the last part one video. Wherever you see 90, that means we have to use SOHCAHTOA. SOHCAHTOA. What does SO stands for? Sine. O stands for opposite. H, hypotenuse. Cos x, adjacent, and again hypotenuse. And finally, tan x equals opposite over adjacent. In this case over here, if this is 90, can I say without any doubt this side 13 has to be my hypotenuse, regardless of where the angle is? The first part of the question says tan BAC. So they're asking us this angle over here. And they're asking us to figure out tan. Which one should I use? This property. So I can say tan BAC is equal to opposite. What's opposite? 5. And what's adjacent? I said this earlier as well. 13 is not the adjacent, 13 is hypotenuse. Can I say right next to this has to be 12? That's it. Again, everyone, it's a paper one question. I've seen many students where they start taking the inverse, they start finding the angle. They don't want you to find the angle. They want you to just figure out the tan of this angle. That's it. I'm done. So in the first blank, I'm supposed to write down 5/12. That's all I had to do. I know this question is a bit unconventional. In a similar way, the second part of the question says cos ACD. Now, again, this is a bit tricky. So let's see which angle they're talking about. ACD. ACD. This angle over here. Wait a second. We haven't done any rule that says this angle can be figured out. We've only done SOHCAHTOA. And we know that SOHCAHTOA is something that's only acceptable inside the triangle where that 90 is forming. So instead of figuring out the angle on the outside, I'm just going to first figure out this cos of ACB. I know that's not what the question is asking. I'm just going to do this on my own. So in this case, we know cos is equal to adjacent over hypotenuse. What's adjacent? 5. What's hypotenuse? 13. Just by looking at it, what do you think? Is this acute or is it obtuse? Is that something which would be in between 0 and 90, or would it be something in between 90 and 180? I am very certain, just by looking at the size of this angle, that it lies in the first quadrant. What did I tell you about cos in the first quadrant? I said it's going to be positive. And what did I explain about the second quadrant? That it's going to be negative. That means, in this case over here, this is something that lies in the first quadrant. And this angle that they're asking us, which is cos ACD, is something that lies in the second quadrant. And we know that the values are exactly the same in the first and second quadrant. It's just in the second quadrant, we have a negative sign right next to it. That's it. That means if the first acute angle is 5/13, then obtuse will be minus 5/13. This is something that's worth, in my opinion, $1 billion. So I hope everyone this is clear as to why is the answer minus 5/13. Again, a very cumbersome question, in my opinion, if you're not taking ad maths. But I hope the concept is slowly building up. Now, similarly, moving on to this last question of this worksheet. The question says in the diagram, ABCD is a straight line. Again, what does that mean? What does the word straight line mean? That somehow it has to be 180. So if that is the case, we can move on to the next part where it says, again, this is also paper one. That means a calculator isn't really allowed. Calculate the value of sine ABD. So they're asking us this. And similarly, cos of ABD. So they're also asking us cos of this as well. Now, like I said, we can't do that. The only thing I can figure out so far that we have studied is based on the SOHCAHTOA principle. And the SOHCAHTOA principle is only applicable inside this bracket or inside this triangle. So I know sine is equal to opposite over hypotenuse. And what is cos equal to? Adjacent over hypotenuse. So here's something I can do. Maybe I can figure out sine of this angle because I know this one lies in the first quadrant. So let's try figuring this out. What do you think sine ABC is going, sine DBC is going to be? Can I say sine DBC is going to be opposite is this side, which we can label out as DC, over hypotenuse, that is 4. Can I say that? And what does DBC represent? Can I say it represents this small b angle? So we can say that this is sine of b. And what is the value of sine b that they have given us? They've given us this angle as 0.85. Now, this wasn't really required because I just realized the question has already given you that sine b is given to you as 0.85. So again, let's try thinking about it. I just said in the first quadrant and in the second quadrant. What's the value of sine in the first quadrant? Positive. What's the value of the sine in the second quadrant? That's also positive. Can I say the values are also the same? Yes. That means if this value, sine of this value is 0.85, I know that sine of this value is also going to be 0.85. So I know that this is also going to be 0.85. In a very similar way, if I know cos of this angle is 0.53, now this again lies in the first quadrant. Cos B is equal to 0.53. Can I say something that lies in the second quadrant? It's just negative. So can't you say cos of ABD is equal to minus 0.53? That means this angle has to be minus 0.53. If you were to calculate this, you should end up getting the answer as 0.32. That's it. Similarly, the second part says to find the value of BC. Now, before I start figuring out BC, my first question to you is what kind of angle is given to us? So they're talking about this triangle over here. And I need adjacent. Can I say BC is adjacent? So which property do you think is applicable? Can I say that has to be cos of B is equal to adjacent, that is BC, over hypotenuse, that is 4? What's the value of cos B? It's given to you as, which is 0.53. So I can label this side as 0.53 is equal to BC over 4. If I were to multiply this 0.53 times 4, this should end up giving me 2.12. That's the value for BC in this case. I hope everyone, this question made sense. And I hope all the queries about the basics of basic trigonometry are clear. I wish you good luck for your exams. Adios.